Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video we are going to explore the load balancer concept along with AWS Fargate. Okay, so in our previous video we have already created a simple Flask API with two endpoints. One is its base endpoint, that is with only / no specific resource path, and if we make a GET request there it will be basically returning hello world. And we have also created another resource path with name publish data which accepts post request, and there if we pass any body along with the API request it will be publishing that particular body part in a Kafka cluster in a specific topic. And in our previous video we have already created the Kafka cluster using Upstash free trial account, right? So there the message is going to be published, and we are running our app in port 50,000. And apart from that, here if you see that we have created our Docker file, because ECS basically Elastic Container Service, it required Docker file, Docker container, Docker images to run our code. So we have created a very simple Docker file to run our Flask app in containerized manner, that we are installing all the necessary modules, we are copying everything to our working directory in Docker environment, that is /app, and we are running Python main.py. okay, right? And here if you see the main.py, it is basically created using Flask API. okay, and apart from that we have also created GitHub action, so that whenever there are some changes made in this particular GitHub repository in this code, automatically a new image will be created in our ECR repository, and from that ECR repository eventually we have created one ECS task definition. So I will open Elastic Container Registry in a new tab, and here I'll be going to repository. So ingest layer was our repo name, and here our image is basically available, which is created using the Docker file, whatever comments we have written, right? And from there, in our earlier video itself, we have created a cluster and the task definition. okay, so here if I go to the task definition section, Flask publisher, this was our task definition. Here we are having our definition of the service, what we are going to launch in ECS cluster. okay, so let me show you a demo by launching the cluster. So here I will go to service section and click on create. Existing cluster I am choosing, Fargate type, that is fine. I am choosing the service and family. So task definition is this one, and I am going to choose the latest version of it. Service name I can give demo flask load yt1, something like this. Service type replica, desired task. Now this is an important part. Eventually this will help us in understanding the load balancer as well, that it is not like in our production system we will have only one task running. We should have multiple worker nodes or tasks which should run parallelly, so that our Flask app can handle huge incoming traffic in a proper manner, right? So just to show you the demo, I am increasing the desired task count. Currently it is 2. okay, right? Service connect, let it be default. And here in the networking section I want to keep it very simple for easy of understanding, that VPC, default VPC what we are having in our AWS account, that one only I am choosing. Subnet, all these default subnets which are associated with this VPC, that all are selected by default, right? And for each subnet in the route table, internet gateway is attached. So in whatever subnet your app will be launched, it will have a scope to connect with internet, right? And then here security group. So for easy of understanding I am going to create a new security group, and here the name let it be as it is, and here inbound rule. So basically in this case the Flask app will be accessing using HTTP request. So we have to make sure that any HTTP request from anywhere it is allowing. So HTTP request you can choose, but if you select HTTP then port range will be kind of fixed, and HTTP by default in the backend implement TCP connection. So instead of HTTP I can opt for all TCP as well, not a problem. And the source can be anywhere IPv4 or IPv6 range, that we can opt for it. Public IP on, that is obvious because this API we want to make publicly accessible. okay, as of now to keep it very simple. And load balancer I am not choosing now. First let's explore what problem we might face without load balancer, and then eventually we will go to the load balancer. okay, right? And then keeping all other properties default, I am going to create our Flask service. So here you can see the deployment is in progress. Let's wait for some time till our service become up and running. So here you can see currently our service creation is in progress state, 0 out of 2 tasks running. So once 2 out of 2 tasks will be running, then we can start using our Flask app. So now here one task is ready to be used and another task is getting ready. So now currently 2 out of 2 tasks are running. So let's just check whether the Flask apps are properly working or not. So if I refresh here, we should see both tasks is in running state. So one is starting with C, another one is starting with E. So I will open the C1 in a new tab and I will open the E1 in another tab. Okay, and then here this is the public IP. So let's try to check whether we are able to access or not. Our Docker file, if you see here, Docker file was running in port this 50,000, our Flask app. So now here if we make a GET request, we should able to see hello world, because here if you see our code, that if we are making a GET request to the base path, we should see hello world. That's what it is happening, right? And now let's try to check the same with another task. So this was our task which we already tested, and another task is starting with E. If I scroll below, this is the public IP. I'll copy that and then here I'll paste it, and then again same port I will try to access, and here also we are getting hello world. That means both of our tasks are accessible. Okay, right? Up to this I hope it is pretty much simple, just what we discussed earlier. Now think like this way, there are some end consumers who want to access this Flask app. So what you can do, maybe you can give them this particular URL as well as this particular URL, and you can ask them to make API call to any of these URLs, right? But the problem will be, as soon as there are some issue and due to some reason if one task goes down, what the ECS service will try to do, it will try to create a new task. Because here if you see in this ECS, if I go inside the service, the configuration what we have done is we need always two tasks as desired value, right? So suppose for example, due to some reason out of these two tasks, one task goes down, what the ECS will try to do, it will try to launch another new task. Okay, because it will try to always maintain the total task count which is running as 2. And that time what will happen, as soon as a new task will be launched, it will have a new public IP. Out of these two public IP, one will not be working and we will be getting a new public IP, right? So the problem is that time to all the Flask app users, you need to provide them the latest IP of that newly created task. So let's see that particular problem practically. So here we are having one task, right? So what I can do, I can click on stop selected. So the task which is starting with C, that one I will try to stop. So stop selected and click on stop. Okay, so here successfully stopped, and here you will see currently in our service only one task is in running state. I can go to the primary level and show you. So here as you can see it is in red color, that means desired count is not met. Eventually our ECS will try to launch a new task. Now if you go to the task section, here you can see another new task is in pending state. So earlier we are having two tasks, one was starting with E, one was starting with C. Okay, now the one which was starting with E, that is still running, but C1 we have stopped intentionally, and now ECS has launched a new task. Okay, so if I refresh, soon it will be in running state as you can see here. And now what will happen, the API endpoint or the URL for the task starting with the character C will not be accessible. That is this one. If I try to access, here you can see it is rotating, and here we are getting the site cannot be reached. And the reason is pretty much obvious. This public IP is released from our this particular task. A new task is launched. This task which is started with C, that is gone, right? So here I can go to task section, and currently we have a new task. I can go inside that, and here this is the new public IP starting with 44. Let's test it out. I will just remove the beginning part and put 44.198.60.34. The port number is anyway same, and if I make a request, here you will see hello world is coming. And the another task which was starting with the character E, that was anyway running. So if I make a request, here the site cannot provide a secured connection. Maybe I can try it once more, or maybe open in a new window for reference. Maybe there were some internet issue or something. I reconnected my internet and let's see. So here if you see, our URL for the task starting with E and the newly launched task, both are accessible now. So here if I make a request, here you can see hello world we are getting, and for the older one also hello world we are getting. Okay, so in between what happened, because one task went down and a new task was launched, the public URL for our Flask app got changed, and all the users who were using the earlier URL, that will not be working. We need to share them the latest API endpoint, and this is a problem. So how we can solve this issue? To solve this issue, we can take help of load balancer. What load balancer will do? It will be sitting in the front of all these tasks which are running in the backend. For all of these URLs, whatever different task is having, for all of them there will be a single common API endpoint which will be created using load balancer, and that will be sitting in the beginning. Okay, whenever some request will be made, the user can make that request to that load balancer endpoint, and the load balancer in the backend will distribute the incoming traffic among all the running tasks. So here we are having two tasks, so in between these two tasks, in round robin fashion or using some other algorithm, the load balancer will distribute that task. Okay, so now we are going to explore that. So here I will be closing my two tasks, and here I will be going to the cluster. Here I will click on this, and I will basically delete this service to show you the demo of the load balancer in a fresh manner, okay, to avoid any confusion. So here I will write delete and delete this. I'll close these two tabs as well because those are no longer required. Okay, so here our older services are deleted, and now I will create a service, and now this time we are going to take help of load balancer. So default properties we can keep as it is. Family, the same task definition we are choosing, right? And same revision. Service name, here I can give Flask app with load balancer YT. Okay, right? Desired task we are keeping 2, and in between these two tasks we want to distribute our incoming traffic, and we don't want to put the IPs of individual tasks. Rather, we want to give a common IP or common API URL endpoint so that the user will be making requests there, and in the backend, if some task goes down, if some new task get launched, the load balancer should automatically put that particular new task endpoint also as a destination and start distributing the incoming traffic in that particular newly launched task as well. Okay, right? So desired task count 2. Okay, networking, here again for this demo I am going to create a new security group, and here I can keep as of now all TCP from anywhere. Okay, public IP turn on, not a problem. Load balancer. Okay, so here this time we need to choose application load balancer because it helps in routing HTTP or HTTPS traffic to different tasks. Okay, so because my traffic is HTTP category, so I am choosing application load balancer, and where it will be forwarding, it will be forwarding to port 50,000 for our Flask app. So here it is basically by default choosing the host port container port. From the task definition mapping, it has automatically detected that. Okay, and then the next important part is application load balancer. So here we are going to create a new load balancer, demo YT Flask API load balancer. Some name I have given. Health check grace period I am keeping default, and listener. So the load balancer will listen the incoming traffic to a specific port, right? So in that case, here we are choosing port 80 as default one, and HTTP protocol only let us choose because we are going to send HTTP request to our load balancer also. Previously what we were sending to individual task public IP, same thing we are going to put here as well. Okay, now target group. What is target group? In simple words, you can think that load balancer is basically a single endpoint. Behind that, we might have multiple ECS tasks running. Load balancer will distribute the incoming traffic among those. So all the task IPs will be basically the target group for our load balancer, or where the distribution of traffic will happen. That is basically considered as target group. Okay, so we are going to create a new target group. Name you can keep as it is. Protocol, here we can choose HTTP protocol, not a problem. So deregistration delay is kind of the amount of time to wait before the state of a deregistration target changes from draining to unused. So maybe you can simply think like this way, that when a task due to some reason get into stopped state, how much time we should wait before draining it from the target group or before excluding it from the target group. Health check protocol HTTP. So load balancer will continuously check the health of our different tasks which is part of our target group, and health check path is basically the base URL we can choose. So what we are trying to say, the load balancer can directly make the request to this particular endpoint and it should get some response. If it is not getting, that means load balancer can eventually understand this task is unhealthy, something like that. Okay, right? This is all change we have to make, and automatically in the backend load balancer will be created by ECS directly. Keeping all other properties default, this time we are going to create the Flask service along with load balancer. And to show you what is happening in the backend, here what I will do, I'll open AWS Management Console in a new tab, and here I will search for load balancer as well. Okay, so here we can go to this, and currently here you can see that one load balancer is in provisioning stage, right? If you see the date created 9:33 p.m. on August 7, currently it is 9:34 p.m. That means in ECS whatever we have configured, due to that in the backend this load balancer is getting created. And some important property if you want to validate, that our ECS service we have launched in the default VPC. The load balancer also launched in the same VPC. Okay, and our ECS service we have launched in all available subnets. Same goes for the load balancer also. The load balancer should be launched in all the subnets which your ECS service is using. It should not happen that your ECS service is using one subnet and your load balancer is launched in another subnet. Obviously that time it will not work. So these network configurations are pretty much intuitive in nature. And here if I scroll below, the load balancer ERN to uniquely identify that, and the DNS name. So DNS name, basically in simple way you can think this became our new API endpoint for our Flask app. We no need to take individual public IP for our running task. We can take this one as a single entry point, and in the backend between all our running tasks, load balancer will eventually uniformly distribute the incoming traffic, right? So let's wait for some time till our load balancer get created. So still it is in provisioning state. And also one more point I want to highlight, that we understood VPC and subnets. Apart from that, the another important aspect in networking is the security group, which is kind of acting like a firewall in our AWS cloud. To understand that, here you can go to the security tab, and here you will see that the load balancer is having the same security group what our ECS service is having. If you want to validate, here I can copy this particular name. I can go to this cluster, and here if you see currently our service is in creation stage, so maybe it is not getting displayed. Once the service will be up and running, I can show you that the service is having same security group, so that load balancer will not have any issue in communicating or distributing the traffic to the service task. Okay, so let's wait for some time. I will show you that also. So here our service creation is in progress. I can go inside that, and here I can go to the configuration and networking section, and here if I scroll below, here you will be getting that the new security group what we have created while launching the service is this one. If I copy that and search here, you will see that the load balancer is basically in that same security group. So it will not have any issue with respect to connectivity, inbound, outbound rule. Everything will be sorted because load balancer is having same security group, right? So let's wait for a few minutes more until our both tasks get deployed. So here both tasks are deployed now. Here if I go inside that, here you will see both are running. Now this time if we want to access our Flask app, we no need to take the public IP from that task, because here we are having our load balancer ready, right? So here this is the DNS name. I can copy that, and in a new tab I can test it out. So this is our load balancer URL, and what is the port? When creating the service we have discussed that the port is 80. In port number 80, load balancer will listen for HTTP traffic. So let's make a GET request, and here you can see we are getting hello world. Okay, so in the backend load balancer has distributed this particular traffic in one of that task, and due to which hello world we are getting, because this particular section of the code got executed, right? I hope you are getting it. And I can show you in the load balancer target group also that it is utilizing these tasks only. So here you can go to the load balancer which is created, and here you will be seeing the protocol HTTP 80. So at port number 80 it is listening to HTTP request, and it is forwarding those requests to this target group. I can open this target group in a new tab, and here you can see the IP addresses where it is forwarding this request is these two. So these two IPs are nothing but our ECS service task IP. I can show you that validation also. Here we can go inside this particular service, and here we are having task. Okay, so both of these tasks I can open in new tabs. Here I can go to the first task, and this is the private IP. Load balancer basically forward the request to the private IP, so I can copy that, and here in the target group if I search, here you will see this IP address is matching. And for the second task if I go and copy this private IP, here if I search, here you will see it is basically forwarding the request to the second task. Okay, so these are our target groups for the load balancer. So the single URL endpoint is forwarding the request to any of these two IPs in the backend. Okay, right? I hope you understood up to this. Even you can check in diagram manner. You can go to the load balancer UI, and here we are having a resource map. You can go inside that. So here you can see whatever HTTP 80 port traffic is coming, it is forwarding to this target group, and target group is forwarding the request to one of this particular IP address which is belonging to our ECS service IP address. Right? Now let's see whether we are able to publish the messages in Kafka as well or not with this same load balancer URL. So for that we will test in same manner how we did earlier. So this is the API testing tool online, and here this time we should not make a post request to this URL directly, but rather our endpoint is publish data. So I'll copy that and paste that here, and let's consider a simple message. We are publishing A:B, and here our Kafka cluster will listen for new messages. So let me just log in. So this is our Kafka cluster. I will go inside that. I will click on messages, and here we will opt for new messages in this captured data topic. Okay, where earlier also we are publishing the messages. Currently it is loading, no new messages. All I will do, I will make a send request. Okay, status code 200 we got. Let's go back to our Kafka console, and a few seconds ago at 9:43 PM on 7th August, which is our today's date, there the message got published A:B. Okay, so now instead of making the request to the task public IP, we are making request to the load balancer, and that's the beauty of load balancer. And now we are going to explore the actual power of load balancing by making multiple requests quickly to this endpoint. Okay, so here what I will do, here I have written a very simple Python code. We are importing the request module, and we are sending post request to the URL endpoint. So our URL is this one. This is load balancer. I will paste this code here. Okay, so HTTP : this is our load balancer DNS name, and then :80, that is in port 80 it will be listening, and publish data is basically our resource path which we want to use to publish messages in Kafka, and send post request. So here we are publishing a very simple JSON structure in the Kafka cluster using this URL endpoint. Okay, and 20 times we are calling, right? So here I will run it, but before running I will open the task logs and close multiple windows to avoid confusions. So here this ECR also not needed, and here this is our service. I'll open both of these tasks in new tabs. And here I can go to the log section. So currently here only get request you will be getting. Maybe load balancer is making this get request for health check, so you can ignore those. And here also I can go to the log section for another task. So here also get request is coming, right? Now what we will do, we will run this code. So quickly, huge volume of traffic will be going to our load balancer, and hopefully it should distribute the traffic uniformly in between two tasks. Okay, but we need to check one thing surely, that one request it is sending to only one task. It should not happen that one single request it is sending to both of these tasks, right? So now let's go back to our this particular task logs, and I will refresh. And here we will see multiple input messages. Okay, that's why I have printed the input messages. Let's go to the beginning section, and here it started with A=2, B=2. That is second message it has published. So hopefully the first message should go to this task. Okay, let's refresh. And here if I scroll below, here you will see that A1 B1 came to this task, and that's why A2 B2 came here. Okay, then here A4 B4 came, right? So A3 B3 will be coming here hopefully somewhere. Yeah, here you can see. Then here in this task the next message is A5 B5. Here the next message is A6 B6, like that. So one request load balancer is sending to one task, the next request it is sending to another task. So to kind of round robin fashion it is following to distribute the incoming traffic between these two tasks in uniform manner, right? So I hope you are getting the feeling that in the backend load balancing is happening, and it is obvious that because A6 B6 came in this particular task, A6 B6 will not be coming here, right? One single request should not be sent to both of these tasks simultaneously, and that also is taken care of by this load balancer, right? And the last point what we are going to explore is, due to some reason, if one of the tasks goes down, whether our load balancer is automatically registering the new task in its target group or not, so that next time when some traffic will be coming, load balancer will forward the traffic to that newly registered task instead of forwarding the traffic to the task which stopped or failed due to some reason. Okay, so that also will inspect. So for that I will open AWS Management Console in a new tab, and I can close the task windows. So here I will search load balancer. So currently we are having this load balancer. I can open the resource map section, which will show clearly currently both of these particular API endpoints for our task is healthy. Now what I will do, let's stop this particular task, okay, which is having IP of this one 172.31.80.220. okay, that is basically this one, right? So let's stop this particular task. Okay, cool. So this particular task is stopped, and automatically ECS service will try to launch a new task, because for this service we have configured that desired task count is 2. Okay, so here if I go to the task section and refresh, here you will see that a new task in provisioning state. Immediately ECS service tried to launch another task so that desired task count will be maintained. Okay, so here let's refresh. Here you can see it is in pending state, and let's see what is happening in load balancer target group. Here if I refresh, here you will see that it is draining out that particular IP address which was belonging to the task which we stopped. So it is draining out, and it will try to automatically onboard the new task IP address. That also will inspect. So here if I refresh, here currently our both task is now again up and running, the newly launched task also running. So in the back end, here you will see that automatically in the target group, earlier we were having only 2 targets. Now this time we have 3 targets, and here the task which was unhealthy, that it is draining automatically, after some time it will be deleted, and now we have these 2 targets. So load balancer will try to distribute the incoming traffic between these 2 target groups. Okay, that also I can show you. Again I'll be making request to this load balancer endpoint, 20 requests quickly, and we will see whether to the newly launched task also request going or not. So this task is newly launched because it is started only 1 minute ago. This was starting since beginning 13 minutes ago. So let's inspect only the logs for this task. If I click on logs, here you will see that A18, B18, A17, B17, okay, A14, B14, A12, B12, like that way messages are getting published in the Kafka cluster using this task as well, right? So load balancer has automatically taken care of onboarding of new task and its IP address, right? So earlier when we were not using the load balancer, the problem what we are facing is, if one task was going down, that time ECS was launching a new task, so IP address was getting changed. The new IP address we needed to forward to all the API users. But this time what is happening, if a new task also get launched, the load balancer endpoint or the DNS name is not getting changed. So although in the backend a running task got stopped or failed, a new task was launched with respect to the end user, there is no change, right? They are using that same API endpoint. Load balancer has automatically onboarded that new task, and it has automatically deregistered that old task. Okay, and that also a very vital point while working with ECS and load balancer. So if you are planning to use AWS ECS to create API, whether you are using Flask or Django or Node.js based API you are creating, whatever, then don't forget to use the load balancer. So that way URL change problem will be solved, and along with that, if you are using load balancer, it brings another very vital point, that one particular task will not be heavily loaded. Okay, it will automatically distribute the workload between its target groups. Like here only 2 are healthy, so it will try to distribute the workload between these 2 tasks, right? So the diagram in short we have tried to implement like this way. So from ECR we have created the task definition, and using the task definition we can launch n number of service. For all of them, in the beginning we can create an application load balancer. From internet the traffic will be coming here, and application load balancer will try to uniformly distribute the traffic between the running task, right? So this is the architecture what we tried to implement in our this video. And whatever request we have made here, obviously if you go to the Apache Kafka cluster, here you will able to see those messages also got published. Like here you can see multiple messages was published, and here pagination also available. So that means our Flask app is properly working, right? I hope you understood this. Try to play with it. Anyway, the code and the reference links I'll be sharing in this particular video description link as well. And if you want to know how the Flask app we have created, don't forget to check the prerequisite link shared in the description box. This is all for this video. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now, and don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.